Hello everyone, so in this video, let us talk about two important problems from LeetCode. The problem name is coin change and coin change 2. So let us start. The first problem is coin change, which states that you are given an integer array coins, as you can see in the input, consisting of different coins of different denominations, as well as an amount representing the total amount of money. Now you have to return the fewest amount of coins that are required to make up this amount. Now you can see that same coin you can take multiple times. So let's say you have some different coins. You have to just form that. You have to form this amount by using as minimum coins as possible from here. Now, the very simplest approach which comes to everyone's mind is just to do a greedy approach here, which means that why not just take the very maximum value and keep on subtracting it from the amount till it is not subtractable. So that then we will take the next smallest and keep on doing that. But in these type of scenarios, if there is not a particular type of denomination style, then that particular type will fail. I will give you a very small example. So it's a very standard example that if you have, let's say, 1, 5, 6, 9, and the total value that you want to reach to is 11. That's a very standard example. So let's say that if you want to get to 11, the very standard approach you will do is just to take one coin of 9, and then you have to add 2 rupees more to just get a total value of 11. So you cannot add this, you cannot add this. So you will eventually just take 2 coins of 1 and you will take 3 coins. But the answer for this is just take actually just 6 and 5, which is a total of 11 itself. So it will just take 2 coins, but now you have taken 3 coins. So just taking the maximum value and then the smaller values is not a correct approach. Also, so greedy is not applicable here, as well as you can see that the total constraints are pretty much small. So in that scenario, it's very easy to just identify that if greedy doesn't work out and the constraints are small enough, you can directly use DP. Now for DP, there's just one thing that you have to understand, that you have to just find out a recursive formula, like how you can recursively solve this problem out, and then just apply memoization to it. The very simplest approach I will try to explain in all the different DP problems I actually solve, and I will be solving out throughout this whole journey of mine. So you will easily understand that. I will link down many different DP problems which I solve, and I will be solving out so that you can get full hands on the way I actually think about DP problems, which is very simple. So you just have to first think about a state. Okay, what is the thing which we can directly reuse to calculate out a bigger problem? To get a bigger problem solution, we can require smaller chunks or smaller values which we can recalculate, and we can store it out, and we can directly use them again and again. So in that scenario, you just have to store those values out. So you just have to calculate out what state, what particular information you can use to store a particular information. So what information we have? We have that for every coin, you have two options. Okay, you can either take that coin or you cannot take that coin. Okay, you can either take that coin or not take that. So every coin has two options. You can just keep on doing that operation again and again. And now what all the things it depends upon? It depends upon the total amount you have. Okay, the total amount of money you have, it depends upon that state, and the coin you are taking. Either you will take this coin or not take this coin. So there are two factors like this whole problem depends upon. So you have to just make a 2D DP array and just try to solve it in a very recursive formula first. The very recursive formula means that you have to just write down the recursive function, just thinking about that. Either you have two options, either you will take it or not take it. So let us try to understand all of this with the code part, because it's very easy to understand with the code part only. So what we have tried to do is that we have called this whole function out. Okay, so we have, as we have understood, we have two things. Okay, we have the index from which we'll start upon, like the first coin, second coin, and so on. So that's why we started from 0, which means that we have to first talk about the 0th coin, second coin, and so on. This is the total amount of money we eventually want to form with these total coins and the total coins we have. We call this recursive function. We have as DP state. So the first value is the index which I am on, and the second value is the total amount. So the index value can go up to 12. So that's why I put it 15 just to take a little buffer. And the maximum amount is 10 to the 4. That's why I just put 10 to the 4 plus 5. Okay, just small buffers. So this is the total maximum DP value we want to store to. Okay. Now for every DP things, there are two things. Okay. The first thing is what is the base condition at which this whole recursion should stop, and the next thing is what is the actual recursive function. So let us talk about first the recursive function. The recursive function is that we have two conditions. For every point, we either will take this particular coin or not take this coin. So we just have to find out the minimum number of coins required. Okay, so what you can see is that either if I do not take this coin, I will recursively call this function again by going to the next index. So index plus 1, amount remains same because I've not taken this current coin, and the same thing. So this is very pretty much simple. The next part is that if I take this coin, the number of coins I have increased because I've taken one more coin for a particular state. So I've taken the coin. So what I'll do is that 1 plus, because I've taken one coin, the next state is recursively call this function again. With that, if I've taken this coin, I might also take this again because I can take this coin multiple times. So I will not move to the next index. Index remains same. But because I've taken this coin, the amount decreased by this amount of coins which I've taken and the coins array. So what you can see is that this is plus 1, which means the number of coins. So both of these state, okay, I will get this state will return the number of coins it will require to get this amount of money, okay, with this index and this coins plus 1 because I've taken this particular coin. So both of these states are there. Whichever is smaller will be the minimum of them, and we will store it on the answer, and before returning out we will just store it in dp. Okay, it is much simple what memorization is. If you have already seen this state, that is index and amount, if it is not equal to 0, which we have already seen this state, we will just return out the dp state. Which pretty much simple what memorization and the recursive part is. Now let us talk about the you can say the base condition. The base condition is that there are two conditions. Either I will hit, I have got the jackpot, I have got the state, I'm looking for a state in which I have got the amount of money. Okay, so what is the state? I at every state, if I'm taking a particular coin, I'm subtracting out that coin money with the amount. So the amount is like getting smaller and smaller. When it will stop? If the amount becomes zero, in that scenario, what will happen? I have particularly got a state. If I've got a state, I have got an answer, I return 0. Why? Because I have been taking out coins in that particular scene. So I have taken one coin, If the total amount of coin becomes 0, which means that I don't have to take any coins because I have taken all the coins throughout this whole process by incrementing 1 here. So I should return 0. But if at any point of case, if the amount becomes less than 0, which means that I have not hit a particular state, I have overshooten, I have taken more coins which I should not be taking out, or if the index, like the coin I am on, I should take it this or not take this coin, if the index which will help us to understand which coin I want to take or not take it, if that goes out of bound of the coins, which means that we have exhausted all the coins, in that scenario we just understand that we have to return a number which is very large. Because I want to minimize my answer, I should return a very large number so that this condition will not hit. I should only focus on these conditions in which we got the answer, because we want to only minimize the number of coins in which we got the answer, not the state which we don't got the answer. In which we don't got the answer, what we can easily do is we can just return a very large number, which means that even if we got this answer, which I actually understand or infer from, that this is a very invalid answer. We do not actually got the answer. I just returned a very large number, which just actually help us to understand that this is not a correct answer. I just returned it to just understand that there is no answer at that particular point, because that is a very large number that will not eventually hit for this particular constraints. So if there is no particular answer for this very large number will be returned. So in the end, I can directly just check out if the answer is equal to this very large number, I will return -1, which means that we have actually not got our answer. This large number is actually just false. I've just returned it for the case of convenience to understand for myself that this is a wrong answer. That's why I return -1. If there is an answer, then I will return the answer. Okay, that's the overall small code. Okay, you just have to understand two parts. The recursive part, for every coin I will take it or not take it, a state, like what is the particular state, and then what all return, like what this particular state holds. This particular state of mine is compromising of the index I am on and the total amount of money left to be made with the index I'm on. And this information in dp stores the minimum number of coins required to get that to the particular state. Because in the end, I also want that if I have this amount of, like all the elements, I am on this particular index, I have this particular amount, what is the minimum number of coins required? That's what it is written from this dp also. That's overall logic for this particular problem. You have all these code. You can pause this video at this particular instance as well to understand this code as well. And if you still have any doubts, you can mention in the comment box of this particular video. Let us move on to the second problem. The second problem is also related to the first problem, but it is a little bit different. It states that you are given against a coins array amount, but you have to return the number of combinations that make up that particular amount. So you can see that you have again the capability to repeat out coins, but you just have to return out the number of ways in which you can get this total amount. Okay, there are multiple ways. As you can see that if I have these coins 1 to 5, I can get 5, the total amount of 5, by just taking one coin, that is 5. I can just take 2, 2 and 1, that is also equal to 5. I can take 2, 1, 1, 1. So there are different combinations of coins I can take out to get a total value of 5. You just have to return the total number of combinations I can get. Like there are actually, how many total number of combinations are there which leads to this particular amount. That's the overall problem statement. Now again, what you can see is that I cannot just do this in a very greedily approach, because the coin problem which we have already talked about, I cannot just take it because I just have to return a total number of ways. So in that scenario as well, we can use DP. So instead of storing out the minimum number of coins, I will use the same approach, but to store now the total number of coins, or the total number of combinations, sorry, for the particular state. Okay, the state is the same, okay, the index and the total amount, but now the state is storing out what is the amount, or actually total number of combinations I have for that particular state. Okay, so let us try to understand again with the code part, because for the recursive part you again have, for for the recursive part, always try to just think of that what is the basic recursive part for this particular problem is. I can either take this coin or not take this coin. Okay, so for every coin I can either take this or not take this. If I'm not taking it, it is also fine. If I take it, it is also fine. But in all the final scenarios, I should get, if I take this or not take this, I should just get out a particular state in which the total sum, the total amount should get equal to 5, and I should just store out the intermediate states. Okay, no, idea is the same. Okay, so now what we can do is, there is also one more optimization we will try to do. I will tell you in the later states, but we will just again do the same thing. We have the, for we just call this recursive function, starting with 0th index, the total amount we want to get to the total number of coins. Okay, this is the DB table, and let's talk about again the first. This is the memorization step. If you have already seen this state, we will return the answer for it again. Why I've stored here -1? Because we have to return the total number of combinations. Okay, the answer for this can be 0 itself. There is no possible way. So you have to return the total number of ways to get that particular ways. So if this mem set, or actually not mem set, this DP should store actually the number of ways to get that particular state to. Okay, but that state value can also be 0. So that is very difficult to just store this as 0 and also check it out as 0. So just make it as -1. Okay, so that everything in this DP table is initialized at -1, and you can just check that if it is not equal to -1, you have already got the answer. You can directly use the DP table. Now for answer, what you have to do is that you have two states again. Okay, you will either take this coin or not take this coin. So what you can directly do is that if you take this coin, if you actually take this coin, then you can again stay at this particular index. You will not move it because you have taken this coin. So index not increased by 1. You have taken this coin, so amount decreased by this number of coin index you have taken. This is the coins array, and the total number of now combinations which are possible with this amount of will be returned, and you just add all the total number of combinations you can get. Okay, this is one of the ways. Other way is you will not take this coin. If you not take this coin, you will index is incremented by 1, amount is doesn't change, and you call this recursive function again. Okay, again answer plus plus, because you're totaling, you are just adding all the total combinations. Okay, and in the end, before returning out, just take this particular state and store the answer and then return it out. Okay. Pretty much simple about the recursive part and the memorization part. Let us talk about the base conditions now. The base condition is pretty much simple as it is, we have talked about. The thing is that if the particular index goes out upon the coins I have, or the total amount of money goes less than 0, then we just return 0. If we have got a particular answer, if my amount becomes 0, because eventually I'm just decreasing about the total number of coins I have by the total coin, I'm decreasing of the amount. Okay, if the total amount turns out to be 0, which means that I have somehow taken different coins, in the end I have got, by particular state I have got my total amount as 0, which means that this particular state which I have got to, just taking out different coins, is correct. So that is particularly one answer. I have got one answer that is perfectly correct. So if my amount becomes 0, which means that the total number of steps that I've taken to get to this particular 0 is correct, so that I will return 1, which means that this is correct 1. This is a correct answer. And if I don't get to this particular state, I will return 0, which means that if I'm doing this particular state transitions, that I'm not going to the particular answer, so answer is 0. These are the things. But if you try to do these things, then it will again give TLE even if you do memorization. So you can also add little bit trick to just reduce our time complexity. That is one more additional top of it. What you can do is, what you can understand is that instead of taking every coin, I will take it or not take it or not take it, you can just do a little bit optimization. What you can do is that for every coin you have now again, I will take it or not take it. But if I just sort all the coins, then if we just understand from here, then let's say if I take it or not take it, if I have take it or not take it, but let's say I the total amount of money, the total amount of, let's say, value that I want to reach to is, let's say, 2. Okay, I just only got a total sum of 2 to get to the final total sum. So let's say my total sum is, let's say, 6. I've taken this coin one time. I've taken this coin one time. Now I've only get, okay, so let's say the total sum is 8. I've taken this coin one time, taken this coin one time, and now I have total value of just 2 left. Okay, let's say 2. And I have already ignored these coins. I am now my index at this point. So is it better to consider that take it or not take it, take it or not take it? 6. Taking 6, and after total number of amount I have is 2, which is less than 6. So just iterating more forward on the right hand side is just waste. Why? Because I just want a total value of 2, but on the right hand side the total is greater than 2. So even if I take this coin or not take this coin, this is just a waste to just go iterating on the right hand side. So it's just waste. So what you can do is that you can optimize it a little bit, in which you can just sort out the whole array first, and if the total amount is less than the coin I am on, you will return 0. Okay, this is one of the case in which you can directly return 0 before checking out all the rest of the states. Because if the amount is already less than the coin I am on, it's not better to just take it or not take it. And also on the right hand side, all the coins will be larger because it is sorting. So it's just better to just return 0 from that particular point, because that state is invalid. Even if I go on the right hand side taking more coins and incrementing my state, it is just bad. So this is one of the optimization you can do to solve this problem a little bit much faster, and it will pass all the different test cases and the time complexities. So that's the whole logic and the code part for the second problem as well. I know that I have not drawn too much, but if you have understood the code part, if you have a little bit knowledge about DP, then it will become very intuitive to you. Okay, it is not too much difficult a problem, but you just have to understand that for every DP problem, you just have to understand the state, and in the state, you just have to understand that can I just generate a recursive function for it? For a recursive function, you just write down the recursive function for it, the base condition, the recursive part, and then just try to do memoization on it, in which you will just create a DP table depending upon the states constraint, and then just apply a memoization here and here. Just apply this line here, that if you have already seen this state before the recursive part, you will just directly return the answer before doing the recursive part. And if you're not seeing the state, do the recursive part, and then before closing out, just store this state value in whatever answer you have got for this particular state, and then return the answer. Okay, that's all. Just small memoization you just have to add on a recursive function, and it will directly just become a TP solution. That's all the logic and the code part for both the problems. If you still have any doubts, you can mention it in the comment box of this particular video. I will see you in the next one. Keep coding, and bye.